let me not disturb you. Ben, I'll check it later. Tell me when you're done, right?
Right.
Sure.
Okay. Welcome back. I'll be fast for the sake of time. Let's quickly do the stuff. Let's finish. We don't want it to look harder than what it is, okay? Let's start with the reduction formulas. So, and we'll see the questions and whatever. All right. Let's derive them. We want to derive the reduction formula for sine to the n of x. Remember, reduction formula, what it is about is, people are not mad, okay, when they do these things, there's always a use. The use is you'll be trying to get a very, very big integral. Now, what you should know is that for big integrals, like these ones, you do by parts, and you'll be doing by parts many, many times. Now, for you to do by parts many times, it will make the job very hard, because remember, by parts is the one where you have two things multiplying, and you'll be saying u dv. Okay, we say the integral of u dv is equal to uv minus the integral of v du. Now, what you should know is that if you have things like this and you're trying to integrate something like this with a very big power, you're going to do by parts for many, many times. If sine has a power of 7, you do by parts 7 times and all that. So for us to do this formula 7 times, that's a lot of work. That's crazy. So we have a shortcut which helps us not to have to do by parts many, many times, and that's reduction formula. So reduction formula is just a shortcut. And I want you to know that you're only going to integrate and differentiate once. So what you're going to do is, they're going to say, okay, can you find the reduction formula of sine to the n of x? Now your job is to quickly find it. You're doing with it as an integral, right? You're doing, we can say, instead of just sine to the n of x, I can say it's the integral of it. So we're saying, for find the reduction formula of the integral of sine to the n of x. So what you're going to say, you're going to say integral of sine to the n of x with respect to x. You're going to do this for sine, you're going to do this for cos. It's the very same thing. You're going to open it up. Even for tan, you're going to open it up, but for tan, you open it up in a little bit of a strong way. For here, you open it up, so you're going to open it up. It becomes sine to the n minus 1 of x by sine x with respect to x. So what we'll be doing here, we change this sine to the n of x to be sine to the n minus 1 times sine, because what actually happens is this sine to the 1. Because they are multiplying, you can still add, right? Oh, sorry for the big eraser, that's a mistake. So everyone can see that. Don't make it hard. Don't you make it hard. Everyone in here can see that the very first thing you're going to do is open up your sine. Open it up. Now when you open it up, you are going to use by parts to now integrate this. It's the same thing as saying sine of n. You've opened it up. Now you want to integrate it. To integrate it, you're going to use by parts. You're going to let this be your u. You're going to let this be your dv. Which means that you are going to say, okay, my u is sine to the n minus 1 of x. Yes, that's the same as for cos. That is what your u will be. So what you're now going to say, you'd say, let u be equal to sine to the n minus 1 of. So this means that it is sine to the n minus 1 of x. With that's du. So now we will say du dx is going to be what would it be? It would be, you want to differentiate, yes, so you drop the power, which is this power, you drop it, n minus 1, you reduce it by 1, it becomes sine to the n minus 2 of x. Then you're going to say, okay, I have my du. Okay, it's like you drop the power, which the power was n minus 1, and you reduce it by 1, the power, and the power is an n minus 2. Okay, it's okay. let's do it. Okay, I'm seeing something which I need to do because something which makes it wrong, and I've seen. It's like, let's differentiate. We said here you can say u is equal to this, which we can say it is sine x, then it is to the power of n minus 1 here. Okay, is the power of n minus 1, which when you're differentiating now, you do it in this form. You drop this power, it becomes n minus 1 without changing the inside. Okay, so it's sine x, and it is now to the n minus 2. Then we multiply by the derivative of the inside. The derivative of sine x is cos x. Then so here we have, okay, no, we would say u dv is uv minus the integral of v du. Okay, now what are we going to do here? What are we going to do? U dv is uv minus the integral. Just plug in the integral of the u dv. You've already seen it. It's sine to the nx and it'll be equal to uv, which u is going to be sine to the n minus 1 and here you'd say it is sine to the n minus 1 of x. Here, and that is the u. Then what do? You say minus the integral of v okay, okay, here what would it be? Du. Go and take your du, right? You take dx to the other side. Du will be, this is v, and what was our v? Our v, it's going to be just one step, okay? Here we have our u, we need to have our dv. Sorry, we need to have our dv to say dv is equal to sine x dx. Integral of dv is the integral of sine x dx. V is equal to, what is the integral of sine x dx? You're going backwards. It will give you negative cos x. Okay? So now we are putting this. Can you see? It will be now, look, you just have to do it this once. You don't have to keep doing. You've done this. This becomes uv. What is my u? Sine to the n minus 1. Okay, it is sine to the n minus 1. Then times u is sine to the n minus 2. Then minus so in here it will be sine to the n, the v. Okay, let's start by putting v. Negative so here what would it be? V du, put du. Sorry. Du would be n minus 1 by sine x to the n minus 2 cos x. So now, what would it be? It would be just x sine I'm trying to bring back some power. Give me a second. I need to go put some water on my face. But this is just one step, okay? Give me a sec. Give me a sec, then I quickly show you what's up. 1 sec. Right. I'm back. I'm back. I needed to put some. My pen is not writing. What do you say? Yo. Okay. Let me change the board. Something's wrong.